Hi, good morning everyone. So today we'll be reviewing the chi-square test of independence. So first we will see the introduction about what is chi-square test and how can we calculate that. Then we will apply that concept for three different use cases. And then finally we will conclude with what's the takeaway and then any question and answers. Okay, so what is chi-square test? So it's basically a test of independence or test of association between the two nominal or ordinal variables. So primarily if you wanted to find out the relationship between two variables, right, or proportion of one variable are different for different values of another variable. So you can use the chi-square test of independence. There are some restrictions on when to use the chi-square test. Basically, the variables have to be nominal or ordinal, and it has to be mutually exclusive. And also, the expected value in the cells should be at least more than 5, and the sample size should not be very low, etc. So, how can we use this how to calculate this chi-square test, or how to perform this test? So you will have the observed values from your survey results, and you might have done some sampling from that. So once you have the observed results, you can calculate the expected values. Once you have the expected values and observed values, so we can calculate the chi-square using the formula given in the slide, which is basically excuse me, summation of observed minus expected the whole squared divided by expected. And then you can also calculate the degree of freedom, which is basically row minus 1 multiplied by column minus 1. So once you have the chi-squared value and the degree of freedom, you can calculate the p-value from your statistical tables. So now once you have the p-value, you have also alpha value, which is 0.05. If p-value is less than the alpha, then you can reject the null hypothesis. Excuse me. This test can also be used to calculate the relationship strength using the Crammer'sV formula. So the formula has been given here. So you can use that to find out. So apart from using these manual formula and methods, there are many different tools which can calculate all these things. So here is the first use case where we used the same data which we collected in the previous survey. So here we are finding the relationship between number of car payments and number of defaults among the participants in Midwest United States. The null hypothesis is there is no relationship between the number of car payments and the number of defaults among the participants in Midwest United States. However, the alternate hypothesis is there is a relationship between the number of car payments and the number of defaults. So we calculated these, we fed the data into PSPP tool, and we calculated this using that tool. And we assumed that the alpha is 0.05. So finally, we got the value of degree of freedom as 6, chi-squared value as 6.68, and the p-value is 0.35, which is much greater than 0.05. Excuse me. So because of that, the null hypothesis is not rejected. So basically, there is no relationship exist. And also, even the Crammer'sV confirms that. So Crammer'sV, if it is like 0 to 0.15, the relationship is very, very weak. And it is even negligible to the level that there is no relationship. So here is the chart. You can view here the chi-squared value, which is 0.35, and also the sample value. Let's move to the second use case. So here we wanted to find the relationship between the comfort level and the number of defaults. So null hypothesis, there is no relationship between these two variables. The alternate hypothesis is there is a relationship between the comfort level and the number of defaults. Excuse me. So we calculated again using PSPP, assuming the alpha is equal to 0.05. So here the chi-squared value is again 6.68 and the p-value is 0.351. So again, since the p-value is much greater than alpha value, we cannot reject the null hypothesis. So finally again, there is no relationship exists. So this is similar to the previous case. And again here the chart with all the details. Let's look at the third use case. So here the number of cars, basically the car payments versus the comfort level. So the null hypothesis is there is no relation, whereas the alternate hypothesis there is a relationship exists between the comfort level and the number of car payments. So we calculated using the PSPP. So here the degree of freedom is 9 and the chi-squared value we got it as 450 and the p-value is almost, it's actually 0.00, which means this is basically less than alpha, which means it is actually we can reject the null hypothesis, right? And the Crammer'sV value is also 1, which means it's pretty strong. There is a very strong relationship between the comfort level and the number of car payments. So we can view this in this chart. So you can view here the chi-squared value is the chi-squared value is 450 and the Crammer'sV strength is 1. So this is basically we can use it to find the Crammer'sV value just for interpretation. We can see based on that whether it's a weak relation or there is no relation, etc. So you can see number 1 is a perfectly symmetric, whereas we also got 0.15, which is very weak. Basically there is no relationship to consider. The key takeaways: the chi-squared were basically used to find the association between two categorical variables. This can be calculated using observed and expected frequency. We also discussed about degree of freedom, and then based on the p-value the hypothesis can be accepted or rejected. Finally, to find the strength we can use the Crammer'sV. Okay, if you have any questions, please post it on the comments and feel free to ask any questions. Thank you for joining with me.